Hey everyone, welcome back to the channel. I'm Johnny, and today we are diving into something absolutely mind-blowing. Did you know that your body is constantly emitting a faint glow? No, this isn't some mystical aura or a superpower you would see in a sci-fi movie. This is real measurable science, and it's called Ultraweak Photon Emission, or UPE for short. Every single cell in your body is giving off this tiny, invincible light. And get this, it might just hold the key to understanding your health and stress levels in ways we are only beginning to explore. Stick around, because this is going to be wild. Picture this. Every cell in your body is like a tiny light bulb, flickering so faintly that you would never see it with the naked eye. But with the right tools, scientists can detect it. And what they are discovering is pretty incredible. This glow isn't just some random phenomenon. It's connected to how your body functions, how it deals with stress, and even how it fights off disease. It's like a secret signals your cells are sending out 24/7. So, why should you care about something you can't even see? Because UP could totally change the game when it comes to monitoring your health. Imagine a future where instead of poking you with needles or running invasive tests, doctors could simply measure the light coming off your skin to figure out how stressed you are or catch early warning signs of trouble. It's completely non-invasive. It's happening naturally inside you right now. And it's got me so hyped to share this with you today. Think about it. No more blood draws, no awkward scans. Just a quick, painless check of your body's own light. It might sound like something straight out of a sci-fi blockbuster, but this is real science, and it's closer to reality than you might think. That's what makes it so exciting. In this video, we are going to break down everything you need to know about UPE. What it is, how scientists manage to detect this hidden glow, and why it could be the next big thing in health and stress monitoring. We will also explore some surprising ways it's already being used, like checking food freshness or helping farmers grow better crops. Plus, we will dig into the challenges holding it back and what the future might hold for this tech. It's a lot to unpack, so grab a drink, get comfy, and let's get started. Alright, let's kick things off with the basics. Ultraweak photon emission is exactly what it sounds like. A super faint light that every living cell in your body emits. And I mean every living thing. We are talking humans, animals, plants, even bacteria. We are all glowing just a little bit. But before you start thinking you are about to light up the night, hold up. This light is about 1,000 times weaker than what our eyes can detect. So it's totally invincible without some high-tech equipment. Here's the deal. Every time your cells do their job, whether it's breaking down food, repairing damage, or just keeping you alive, they produce this tiny amount of light. It's not like the bright glow of a firefly that you can spot from across the yard. UPE is more like a whisper of light. So subtle, so quiet, you would never know it's there unless you are looking for it. If you are imagining yourself glowing like a superhero right now, I hate to break it to you. It's not that kind of light. UPE operates in the ultraviolet to visible range, roughly 200 to 1000 nanometers, and is made up of a single photons. Photons are the tiniest building blocks of light, and with UPE, they are so sparse and weak that they are more like a faint signal than a dazzling beam. So no, you are not going to be lighting up the dark anytime soon. While it won't turn you into a human flashlight, this glow is still a big deal. It's a natural part of being alive, and it's been happening inside you since day one. That faint signal might not look like much, but it's packed with information about what's going on in your body. So where does this glow even come from? It all ties back to metabolism, the process your cells use to turn food into energy. A major player in this is something called reactive oxygen species, or ROS for short. Think of ROS as the exhaust your cellular engine pumps out. When your cells are running smoothly, they produce these molecules as a normal byproduct. But when you stress out, maybe from a crazy day at work or a tough workout, ROS levels can spike. Here's where it gets interesting. Too much ROS leads to what's called oxidative stress, which is like your cells being under siege. It can damage your DNA, proteins, and fats. And it's linked to things like aging, inflammation, and serious conditions like cancer or Alzheimer's. As ROS calm down, they release their extra energy as these ultra-weak photons. So UPE is basically your cell's way of signaling how they are handling stress, or if they are struggling to keep up. This isn't some brand new discovery either. It's got a cool history. Way back in the 1920s, a Russian biologist named Alexander Gurevich noticed that cells seem to give off some kind of radiation. He called it mitogenic rays and thought it might help cells grow. But most folk at the time just shrugged it off. Fast forward to the 1970s, and a German biophysicist named Fritz Albert Popp picked up the idea. He called these emissions biophotons and spent years studying them, even suggesting that might be how cells talk to each other. That last part is still up for debate, but his work definitely put UPE on the scientific radar. Today we know UPE isn't some woo-woo energy field. It's a chemistry at work. It's a measurable, repeatable process tied to the everyday functions of life. And with modern tools, we are starting to unlock just how much it can tell us about ourselves and the world around us. Since UPE is way too faint for our eyes to catch, scientists need some serious tech to see it. The go-to tool is the Electron Multiplying Charge Coupled Device Camera, or EMCCD. These aren't your average phone cameras. They are built to detect single photons with over 90% efficiency. That means they pick up almost every tiny flicker of light, even when it's pitch black. Imagine it like this. If a single photon is a drop of water, an EMCCD is a bucket that catches nearly every single one, no matter how small. It's this kind of precision that turns UPE from an invisible quirk into something we can actually study and understand. Here is how they do it. Measuring UPE requires a completely dark environment. I mean completely dark. No windows, no phone screens, not even a tiny LED. Why? Because even the smallest bit of stray light, like from a street lamp blocks away, would drown out the signal. It's like trying to hear a whisper in the middle of a rock concert. Scientists set up these dark chambers, pop their subject inside, could be humans, animals, or plants, and let the process begin. It's a bit like developing old film in a dark room. Everything has to be perfect for the picture to come out clear. Once the room's dark, the EMCCD needs about 10 to 20 minutes to adapt, kind of letting your eyes adjust to the dark, but way more high-tech. It's chilled to crazy low temperatures, like negative 80 degrees Celsius, to cut down on thermal noise. Random signals that could mess up the readings. Then it starts snapping images, building a map of where those faint photons are popping up. It's a slow, careful process, but the results are stunning. You end up with a visual snapshot of life itself, glowing faintly but steadily, a map of energy in action. The images can blow your mind. In one study, researchers used an EMCCD to scan live mice and saw bright, colorful hotspots of UPE all over their bodies, proof of life doing its thing. Then they scanned the same mice after they passed away, and the glow was almost completely gone. It's a powerful reminder that this light is tied to living processes. This isn't just me, it's profound. It shows UPE is a marker of life and health. When the glow fades, it's a sign something's off. which is why scientists are so excited about what it could mean. Now let's get into why UPE could matter to you personally. It's like a health report card hidden in your glow. Since it's linked to your ROS and oxidative stress, it's basically a real-time readout of how your cells are coping. Oxidative stress isn't just a fancy term. It's what happens when ROS overwhelms your cell's defenses, and it's tied to aging, inflammation, and big health issues like heart disease, diabetes, and even mental health challenges. In short, UPE is your body's way of waving a little flag when something's up. It's a signal we can measure without poking or prodding. Just pure natural light telling a story about your well-being. When you are stressed out, whether it's mental stress from a rough day or physical stress from pushing your body, your ROS levels climb and your UPE spikes right along with them. It's like your cells are shouting, "We are working hard here." Lab studies back this up. Expose skin cells to a stressor like hydrogen peroxide and their photon output jumps. In people, mental stress like anxiety and burnout shows up on the UPE map too. This could be huge, a non-invasive way to track stress as it happens. Imagine knowing your stress levels are climbing before you even feel overwhelmed, giving you a chance to take a breather. Here is the dream scenario: using UPE to keep tabs on your health without any invasive stuff. Picture a doctor scanning your glow to check for inflammation, measure stress, or even evaluate organs for transplants. Living tissue glows, dead tissue doesn't. A 2016 review in PLOS1 called it a non-invasive window into biochemical stress, and dermatologists are already looking at it for skin health clues. It's still early, but the possibilities are massive. This could simplify health checkups, making them safer, faster, and way more comfortable for everyone. It's not just about us humans. Plants, animals, and even microbes glow too. That shared glow means UPE could teach us about life in general. Stressed plants pump out more photons. Dying bacteria fade out. It's like a universal language of life we are just starting to decode. This could stretch across industries, from farming to biotech, showing us how connected all living things are through this faint, fascinating light. So how could UPE fit into your everyday life? First up, personal health tracking. Imagine a wearable like a smartwatch that measures your UPE along your steps or heart rate, alerting you when stress is sneaking up. Chronic stress is a quiet health wrecker. UPE could shine a light on it and help you manage it. Here's the scene. You are heading into a big meeting, but your wearable buzzes. Your glow spiking, signaling stress. You take a moment to breathe, reset, and go in feeling stronger. That's the kind of instant feedback UPE could bring to the table. In farming, UPE could spot plant stress before it's too late. Things like drought, pests, or heat boost a plant's photon output. Farmers could use drones or handheld scanners to check fields, catching problems early and protecting their crops. It's like giving farmers X-ray vision for plant health, seeing stress before it turns into a crop failure. With climate change making farming tougher, this could be a lifesaver for food production. Then there is food quality. As fruits, veggies, or grains start to spoil, oxidations kick in, ramping up UPE. Researchers are working on scanners to check freshness without cutting anything open. No mess, no waste. Imagine a little gadget at the store saying, "This peach is perfect," or a smart packaging that lights up when your greens go bad. It's a simple way to cut food waste and keep your fridge stocked with the good stuff. It could even go industrial. Think quality control in biotech. or monitoring microbial health in labs. The bigger picture, UPE could slip into your daily routine, from your wrist to your kitchen, turning a faint glow into practical everyday info. The uses are endless. UPE might not be mainstream yet, but it's got the chops to touch so many corners of our lives. But here's the reality check. UPE isn't ready for your home just yet. EMCCDs cost tens of thousands of dollars and need dark controlled setups. A stray light, a shaky hand, or a warm room can throw off the data. It's high-end lab gear, not something you would pick up at the store. Right now, UPE tech is like a luxury sports car. Amazing, but not practical for most of us. To go mainstream, it needs to get cheaper, smaller, and way easier to use. The science isn't fully baked either. UPE shows stress, no doubt, but tying it to specific conditions like this glow means diabetes needs more research. Things like your diet, the weather, or even your mood could tweak the signal. So scientists are still figuring out how to filter the noise. It's like tuning a radio station. There is a signal, but it's not crystal clear yet. The good news? Every new study sharpens the picture a little more. What's the fix? Smaller, cheaper sensors, like cooled CMOS chips or portable photon detectors. If those hit the market, UPE could shrink from a lab giant to a pocket-sized tool. Imagine a phone attachment or a patch that tracks your glow all day, syncing to an app with tips to relax when you are lighting up too much. This isn't just about health. It's about weaving UPE into your life, like checking your weather app or fitness tracker. Simple, seamless, and super useful. Looking long-term, UPE could redefine health tech, non-invasive, universal, and tied to the essence of life. It's not just about catching problems. It's about understanding what being alive really looks like, from your cells to your groceries. Picture a world where your glow is as normal a check as your pulse. It's a future where health monitoring feels natural, effortless, and maybe even a little magical. And that's Ultraweak Photon Emission, your body's secret light show. It's a window into your cells, a stress signal, and a potential game changer for health, food, and farming. The fact that it's non-invasive and universal makes it one of the most fascinating things I have explored in this channel. From cutting-edge labs to your everyday life, UPE shows us there is so much we can't see. But with the right tools, we can learn so much more about ourselves and the world. What I love most about UPE is how it flips health monitoring on its head. No needles, no stress, just a camera picking up the light you are already giving off. It's a reminder of how amazing our bodies are, even in ways we don't notice. And who knows, in a few years, checking your glow might be as routine as weighing yourself. Thanks for joining me in this deep dive. If you are as hooked on UPE as I am, hit that like button, subscribe if you haven't, and share this with someone who would love it too. Down in the comments, tell me, what do you think about this tech? Could it change how you keep tabs on your health? Or is it still too out there for you? I read every comment, so let's talk about it. Until next time, keep glowing, literally. Catch you in the next one.